Hi, good morning everyone. This is Kumar. Welcome to BBC channel. I would explain about double-ended queue. That is also called a DEQs. A DEQ is a homogeneous list in which elements can be added or inserted. The add or insert means is called a push operation and delete or remove from both ends. Insertion and deletion can perform both ends. The deletion are called pop operation. We can add a new element at the rear or front end, and also we can remove an element from both front and rear ends. Hence, it is called double-ended queue. The double-ended queue operations can perform both ends, front and rear. The front can insert and delete also, and at the same time rear end also can perform insert and delete. That's why it is called a double-ended queue or DEQs. Like this is for rear, this is for front end and rear end. The front end using push operation, that is the insertion. Delete operation can pop operation. Front using front end. Push and pop. At the same way, rear end also can perform push and pop operation. That is the double-ended queue. Like this. Additions or deletions can perform both ends. Front end and rear end also. That's why it is called a double-ended queue. There are two types of DEQ depending upon the restriction to perform insertion or deletion operations at the two ends. Some of the restrictions in insertions and deletions. Based on that, there are two types. The first one is input restricted DEQ. The first one is input restricted, and second one is output restricted. There are two types of DEQs. Double-ended queues are two types: input restricted DEQ and output restricted DEQ. Input restricted and output restricted double-ended queues. First one, what is input restrictions? Input restricted means which allows insertion at only one end. Insertion can perform only one end, that is rear end. Insertion can perform only rear end, but allows deletion both ends, rear and front. It means, for example, like this is a queue. This is for front end. This is for rear end. Insertion at only one end, rear end. That means insertion can perform rear end only. Deletions can perform, it means deletion can perform front end and rear end also. The both ends can deletions, only one insertion, one end insertions, that is the rear end. And another one, output restriction. Output restricted, which allows deletion at only one end. deletion only one end, that is front end, but allows insertion at both ends, rear and front ends. That is, for example, it is in a queue. This is for the front end, this is for the rear end. The deletion at only one end, that is the front end. Deletion can perform only front end, but allow insertion at both ends. It means using rear end insertion is possible and front end also insertion is possible. That is the output restricted, the input restricted and output restricted. Input restricted insertion can perform only one end, that is rear end. The deletions can perform front and rear. The output restricted deletion at only one end, that is the front end, and insertion can perform both ends, that is the rear and front end. The possible operations performed on DQs are mainly four types of operation. That is the first one, add an element at the rear end. The first operation, the add an element at rear end. The second one, add an element at front end. Add element at front end. It means the insertion can perform rear end and front end. The third one, delete an element from front end. Delete an element from front end and delete an element from rear end. It means the four operations, deletion and insertions, can perform both the ends, front end and rear end. Deletion can perform both the ends. The same way, insertion can perform both the ends. So, the mainly four operations, insertions 2 and deletions 2. And the first, third and fourth operations are performed by input restricted DQ. Because of input restricted DQ perform insertion at one end, deletion can perform two ends. That's why first, third and fourth operations are performed input restricted DQ, and first, second and third operations are performed output restricted, because the output restricted DQ insertion can perform both the ends, front and rear ends, but deletion can perform only one end. That's why the first, second and third operations are using for the output restricted, and first, third and fourth operations are performed input restricted. Okay. The next one, algorithms. Insert an element at the right side of the DQ. Right side of the DQ. In this, the first, read the data. Because of insertion based on the data. In this, first, check the left equal to 0 and right maximum minus 1. It means the size of the queue. Left equal to 0 and right size of size minus 1 or left equal to right plus 1. It means that is the queue overflow. It means the queue is full. So simply exit. Otherwise, if left equal to minus 1, it means it is in a first element of the insertion. So left equal to 0 and right equal to 0 to assign. Because of the 0th indexing the first element of the queue. Otherwise, if right equal to max minus 1, it means size minus 1, right equal to 0 to assign the right equal to 0. Otherwise, increase the right pointer, it means right equal to right plus 1, then the read data are stored to the queue. Simply exit. That is the insert an element at the right side of the DQ. And another algorithm, insertion at left side. Insert an element at the left side of the DEQ. The same way, read data means input data and check the first condition, queue is full or not. Again, the same conditions, left equal to 0 and right equal to minus 1 or left equal to right plus 1. The simply queue is overflow. It means queue is full. The simply exit. Otherwise, left equal to minus 1, it means it is in a first value of the queue. So simply assign left equal to 0 and right equals 0. Because of it is in a single element, the both indexing or left and right are the 0th position. Otherwise, else if left equal to 0, right equal to size minus 1, that is the max minus 1 to assign the left pointer. Otherwise, left equal to left minus 1, then the read data store to the queue of left. This is the insertion an element at the left side of the double-ended queue. The another algorithm, DQ. It means deletions. Delete an element from the right side of the queue. It means perform deletion right side. First check the queue is underflow or not. It means queue is empty or not. So first check the if left equal to minus 1, simply queue is underflow and exit. Otherwise, remove to possible the queue. So first the right value assigned to the data, it means the simply prints the deleted data, and if left equal to right, it means it is in a single value. The left and right is representing one pointer, that is the only one value in queue. That's why they simply assign left equal to minus 1 and right equal to minus 1. Because of it's a one value or deleted, it's in a queue is empty. That's why left equal to minus 1 and right equal to minus 1. Otherwise, else if right equal to 0, the simply the size minus 1 to assign to the right pointer. That is the max minus 1 minus 1. The right equal to max minus 1. Else right equal to right minus 1. Decrease the right pointer, then exit the delete right. And another deletion operation, delete an element from the left side of the double-ended queue, that is the DEQ. So it is also check the first queue is empty or not. That's why if left equal to minus 1, the queue is underflow. That means queue is empty. So simply exit. Otherwise, queue left. It means left pointer value are stored to the data and prints the information. Then if left equal to right, it means left equal to right means it is in a only one value in the queue. That's why the left equal to minus 1 and right equal to minus 1, because of after one value deleted the queue is empty, so right and left pointers are representing for the minus 1, so it is in a underflow. Otherwise, if left equal to max minus 1, so 0 to assign the left equal to size minus 1, that is the 0 to assign the left pointer. Otherwise, left equal to left plus 1, it means it is a increase the left pointer value, because of one value are deleted, so simply increase the left pointer and exit. These were the algorithms for DEQ. Thank you very much.